Perfect. Welcome to this new video. In this one, I will show you one of the free techniques of our malware technique database. That basically it's the classic process injection in Windows. Okay, so let's try to understand what we are doing here. Basically, it's a technique where a program opens a target process, allocates memory inside it, writes malicious code into that memory, and creates a remote thread to execute the injected payload. Okay. So basically, we are injecting malicious shellcode or any shellcode to an remote process. Okay, so instead of execute our malware in our process, we're just injecting this malware into a remote process to perform the operations in a remote process and not be killed in our own local process. Okay. The steps are very simple. Okay, first of all, we need to find the target process, the victim process. Then we open a process to this target process. We allocate a new memory inside this process. We write the shellcode into this new memory space, and we create a remote thread pointing to the memory region with the shellcode inside it. Okay, the code is pretty simple, and to understand the code, let's just jump to the virtual machine. Perfect. So basically here we have the code. Okay, first of all, if you execute this in your local machine, always remember to stop Windows Defender. Okay, this shellcode and this technique will be automatically detected as malicious. Okay, so if you want to try this, you remember to exclude, like in my case, I have just excluded this path, or directly stop or disable the Windows Defender for testing purposes. Okay. Perfect. So here we start declaring a shellcode. This shellcode is just created with MSF Venom, and if I'm not bad, this shellcode is just executing a calc.exe process. Okay, a typical Windows calculator process. Perfect. Perfect. After this, we can just scroll a little bit to the main function, and here is where the magic happens. Basically, first of all, we get the process ID of the process that you want to inject to. Okay, so in this case, the victim process will be the notepad process, and this is the typical function, typical Windows function, to get the process ID by the process name. So you pass the process name, in this case, notepad.exe, as the parameter, and with this library to create a snapshot of all the running processes, you can get with a simple loop, you can try to find this running process. Okay, if we find the process, we just return the process ID in the function. So here we will have the process ID of the notepad process. In case that the notepad process is executed, if the notepad process is not running, the process ID will be 0, and you will enter to this case from here. Okay, perfect. So then we can just start playing with the victim process. The first things that we need to do is to open the process. Okay, this open process is just so simple. This receives the desired access that you want to the process. In this case, we want the all access, a full access. Then here we set a false. This parameter is the inherit one. Okay, though we don't want to inherit the handle, so that's not important. And in the third one, we pass the process ID. Okay, so basically, this function will return a handle to the victim process, to the opponent process, that contains the process that's identified with the process ID that we have just get from the previous function. So with the notepad process ID. So the result is a handle to the notepad process. So once we have the handle, we can just start playing with the memory, with the shellcode. Okay. So before we write our shellcode in the victim process, we need a site where we can write this. To do this, we use the virtual alloc.ex function. Okay, this function is just allocating or creating a new memory space in the victim process. Okay, basically it's so simple. This receives the following parameters. The first of the parameters is just the handle of the process. So the process handle returned by the previous open process call function, it's the first parameter of this. Okay, then the second address, the second parameter is the address. In this case, we set a null address because we don't have a problem if any random memory allocation, memory position, memory address of the victim process it's used. So in this case, we set a null address because we don't give a fuck about where of the victim process our memory space is created. After this, we need to set the size of this new memory space. In this case, it's the shellcode size, the size of the shellcode that we will write inside them. Then we just set the mem commit and mem reserve. And finally, we set execute read write permissions. Here, you always have the option to set just page execute write. Here, you write your shellcode, and then with the virtual protect function, you just go back to a page read execute, and you will able to perform the same actions. Lately, the antivirus are looking for this pattern, and my recommendation is just set the page execute read write from the first stage of the process injection. Okay, perfect. So after this, we just print the memory space, the address of the memory space, and we can just jump to the next one, the step where we are writing the shellcode to the new allocated memory. Okay. This write process memory function call, it's very simple. Receives the first parameter, the same handle, open it with open process function, then the memory address of the new allocated memory space. So this is the memory address that we need to write with our shellcode. Then which data you need to write to this new memory address, in this case directly the shellcode. Remember, it's this one from here. You set here the shellcode, and then you need to set the shellcode size, how many bytes you need to write. And this last parameter is just an output parameter to show how many bytes are written. Okay, using, for example, this write process memory, write this number of bytes in this shellcode address. Okay, perfect. So with the write process memory, we can just write our shellcode into the malicious space of the victim process, and then the last step is here. It's the step to create a thread in the victim process to execute the shellcode. Okay, that's pretty simple. We just call the create remote thread function. The first parameter, it's the same handle, open it with the open process function. Then we set a null to the thread attributes. We set a 0 here to this parameter from here that reminds to the stack size. And then the most important part goes here, the LP start address parameter. Okay, this parameter you basically need to set the memory that will be executed in the first step of the thread. So basically the first RIP address. In this case, we are setting the address of the memory of the allocated memory of the created memory space where we have just written our shellcode inside it. So when your thread is created, will go directly to this address, and in this address we have our malicious shellcode that when receive a thread in this address will be automatically executed. So the result is the created remote thread executing our classic calc.exe shellcode process. Okay. Perfect. So that's all. Let's just see the proof of concept. Proof of concept is very easy. You just need to open a notepad process and then execute the code. You wait a second because this machine is a little bit slow. Wait a second. And if all works good, the calculator process will be executed. Okay, perfect. That's all. That's all for this technique. It's just this. It's a classic technique. Remember, this will not evade any type of defense. Okay, all the security software, even Windows Defender, detects automatically this code as a malicious one. But it's important because it's one of the basic techniques in malware development. Okay, perfect. So that's all. That's all for this technique. Let's just jump to the next one.